All right, it's with great pleasure today that I get to introduce our first guest speaker. Joe McGaunn is a graduate of Masconomet Regional High School of 2016. I don't want to say too much about maybe how we met, but our story is kind of unique. I never taught Joe, which is also unique in this sort of situation, but I do feel that he and I developed a relationship over time that was about a love of science. It was about shared people that we knew and spent our time with. And we've kept in touch to the point where I even did witness and watch his dissertation, his defense of his thesis really last, not thesis, but his project at UMass Amherst this last spring in May. So he's joining us today. I don't want to give too much of his background because I think he's going to share that. But it is a pleasure to have Joe join us today. I know that I'm excited to hear what he has to say. And he has a lot to share with you folks, especially as you're starting your paths and potential careers in science and pursuits. So Joe, thanks for joining us today.
Yeah, thank you so much for having me. I'm absolutely honored to kick this off. First thing I just want to share, feel free to send messages in the chat while I'm talking, or if it's important and you think I'm going to go on to a different point, interrupt me with a question that I might be able to answer so you don't have to keep it in your head until the end of the discussion. So let me just get this slideshow going. And yeah, so my talk is entitled First Steps on a Path to Science. How do I start and where can I go? As Ms. Faye said, I'm from Masco. I graduated in 2016. And another thing I want to mention is after this, I'm going to share my contact info. Feel free to reach out to me afterwards to chat about college, science, medicine, finding internships, and more. I am a resource for you, and I want to help you out how I can because I love when other people start doing science. So yeah, I'm a huge science nerd. This is me. This is my really the only good picture of me out there. But if you're here, you're probably interested in science too, because this is a science league after all. And you're probably also asking a few different questions that I was asking in high school. And this is kind of me thinking about what you might be saying based on my own experience. And so the first thing is really, can someone like me actually do real science? Like we see that in like the media today, especially like we're talking about all these different kinds of science. And can someone like me actually do that? How do I learn if science is right for me? How can I actually start doing science? And what specifically can I do with it? Where can a scientific career take me? Science is really, really broad. And so I'd like to chat a bit about that. As you go through your time learning about science, learning whether you would like to do it, you're gonna have to make a lot of decisions, like a lot. There are gonna be a lot of things that you have to learn and think about and decide with sometimes a lot of information, sometimes very little. And so it's really important that we think about how to make these kinds of decisions to learn about like which career paths we might like or what might be good for us in terms of like life path well. And I personally don't have all the answers. I'm really also just starting out, but I can share what I've learned along the way. I can share my story. And I also have some resources at the end of this that I would like to share with you too. So maybe we should start with where I am now. And so where I am right now is this big building. I'm in there right now. It's called the Broad Institute. It's a biomedical research building in Cambridge. My specific title is Research Associate, which means I work with different people who have a PhD, different people who have an MD who do like work with patients. And I work kind of in the spirit of the mission of the Broad, which is really to improve human health by using genomics and other methods to understand disease biology, how to treat disease, and lay the groundwork for new therapies. The cool thing about this was that it sprung up around the Human Genome Project back in the 2000s. They really wanted to know, well, we have all this data. We've sequenced the whole human genome, literally thousands of genes. How are we going to learn about them? How are we going to understand them? And so these people got together and they put together a lot of skilled biologists, a lot of skilled computer scientists to work together to understand large sets of biological data. And so that's what this is all about here. What am I doing specifically? I'm investigating how a developmental cancer drug works. It's a targeted cancer drug, which means that it is designed to kill cancer cells, but not regular cells. And that's good because it won't be very, very toxic like a lot of chemotherapies are. And so I work in the Meyerson lab under this guy, Matthew Meyerson. And we use biochemistry, genomics, and cell biology to probe what all of these different kinds of drugs may be doing in cancer cells. And it's really important to know how a cancer drug works, because if you want to bring it to the clinic, you need to understand it, because you don't want to not miss something in clinical trials, though you're also still learning things through those as well. And we all collaborate with a pharmaceutical company as well to develop our cancer therapies. And the specific project I'm on is all about cancer cells that are sensitive to a drug called DNMDP. And these cells have a super high level of two proteins, PDE3A and Schlafen-12. And these two proteins, for some reason, when given DNMDP, form a complex, and that causes cancer cells to die. We have no idea really why. Like, we have some inklings, which I can't talk about yet, but maybe in the future. It's proprietary right now. But we're trying to get an understanding of how this complex formation actually kills cancer cells, and only cancer cells with high amounts of these proteins. And so that's my goal right now. But I didn't really start there. I started at Masco, and this was me looking real awkward out in front of the Topsfield Library. But yeah, in high school, starting out, I'm guessing like a lot of you, I thought that science was cool. I love my science classes, and specifically, I was super interested in discovering stuff in biology to help people. I thought that was so cool. I thought the idea of like the guy who discovered insulin and helped my grandfather not die because he could use insulin to survive having diabetes was very, very cool, and very, very important. And I want to help contribute to things like that. I want to help cure and prevent disease. The thing is, I knew that there were kind of like two career paths, and one was research, where you get a PhD, and the other was medicine, where you usually get an MD. But I didn't really know how to start doing either of those two paths, how to do like, quote, research science or medicine, partly because I couldn't find any opportunities. I spent a lot of time looking and nothing was popping up, partly because, well, a lot of people kept saying to me, come back when you have a college degree, which is understandable. But I knew there were opportunities for high school students out there, but I just couldn't find them. I also didn't know whether I would actually enjoy science or not, or whether I was actually capable of doing it. I'd never really done it outside of like lab classes where we were told the procedure and we were told what the end result should be, rather than having to figure it out for ourselves. And specifically, I didn't really know how to choose between these two careers that I thought kind of fit what I was interested in, an MD or a PhD. And weirdly enough, at a running camp, Granite State running camp in up in New Hampshire with the Masconomet cross country team, I learned that you can do both. And so every day, someone would come in and give a talk about running at this camp. And so I wasn't really focused on science here at all. I was focused on working out, having fun, that sort of thing. But one day, this woman, Dr. Stavas, here in the middle picture, she was featured as a 2013 Bostonian of the Year, which I thought was cool. She came in and started talking about how physical activity can influence the neurobiology of altruism, or the desire to help people without necessarily needing anything in return. And to me, that was a bit of an emotional experience, because it was a chance to, it showed me that you could do science and medicine and it can have a social impact. And I thought that was so cool. How can I do that? That was what I wanted to know. I was so amped about that. It was in my college essay. I couldn't stop talking about it. Yeah, it made my week. And so afterwards, I went up to her and I asked her thoughts on research versus medicine, because like I was thinking about these two careers, and here was an actual doctor that like I hadn't been able to talk to a doctor before. And here was one right in front of me, and I had to ask my questions. I had to know. And so I asked her, like, what do you think? How do I decide to do research or medicine? And she said, really, you just got to try it out. But if you're crazy enough, you can do both. And I wondered if I was crazy. And so far, the answer is yes. And she also told me there are specific programs for it, MD, PhD programs. There are other ways to do both research and medicine, but this is the thing that stuck out to me from our conversation. And I would have had no idea about this if I hadn't asked. My parents are not in science at all. I don't really know anyone or didn't know anyone who was currently doing science. And so I wouldn't have known anything about this if I hadn't asked. So I made a plan, and my goal was really how to know what I want to do for sure. And I decided to experiment, and I spent senior year doing this. And my goal was to test what I wanted to do through different experiences. So first, I decided to do more science classes, AP chemistry, AP physics, things like that. I took some online classes about just intro to biology through an online service. I also joined an EMT class that Masconomet offered. And then I also tried to talk to more and more people as I could, like different teachers like Miss Fay or my chemistry teacher, Miss Lund. I imagine some of you might have Miss Lund right now. And then my fourth thing was to actually find a research experience, a good internship opportunity for senior year. Because at Masco, one thing we do is we often do an internship in the fourth quarter of senior year. And so, Ms. Fay, I may need you to jump in here a little bit to help share this story. But a friend introduced me to Ms. Fay since we both want to do a science internship together. And Ms. Fay and I talked, and we didn't really know each other, so it wasn't clear whether I was really qualified. It wasn't really clear whether it was the right thing to to learn about opportunities through Ms. Fay. The reason I wanted to talk to her was because a lot of people who had taken her biology classes, she helped them get internships through some of her affiliations with Harvard Life Science Outreach. And so it ended up working out, but it took a lot of work on Ms. Fay's part. It wasn't set in stone. And I almost ended up putting all my eggs in one basket, which was not the wisest thing to do. It would have been wiser to look for other opportunities, which I ended up trying to make sure I did at the last minute. But thankfully, things came through and worked out. And Ms. Fay informed my friend and I that I had a chance to actually go to a lab and learn some science. But I had to make it very clear that I was willing to put in the work to learn what I had to make sure that I was qualified to go to this. And I also talked to different teachers to see if they could recommend me, that sort of thing, like teachers that I actually knew. And when I went to Harvard Life Sciences Outreach, I worked with someone named Alia. She ran part of their program there. And I learned basic lab techniques, how to pipette, polymerase chain reaction, how to transform bacteria, gel electrophoresis, and more. And our goal after learning those was to fix a PCR experiment that a lot of people had or were trying to use there that wasn't working. They were using it to teach people how to do PCR. And so I had to do some experiments to fix it. And we ended up doing that. And we ended up actually teaching others how to do it, how to learn about science. And I thought that was just watching other people pick up a pipette for the first time. And even though I had really just done it myself and get really excited about science, really kind of showed me how powerful science is. In a way, and this was also brought to my attention by a TED Talk that Alia showed me, led by this person, Pardis Sabeti. Science and scientific thinking is really helpful for solving a lot of big problems in the world. And being able to see the fact that I was able to help all these people learn science made me feel like I might be able to do it. And I also really learned that I liked science education and communication too. And that's really one reason I'm here. The next step for me was to graduate, and I ended up going to UMass Amherst because I wanted to be able to afford college a little bit. In my financial situation, UMass was by far the cheapest as a public school. And so I went there. It ended up being a really good decision because there were a lot of research opportunities too. When I got there, I knew I had some interests, specifically the life sciences, medicine, academic research, maybe working in the biotech industry, as I learned a bit from, I learned all of these through my time at Harvard Life Sciences Outreach. And maybe I wanted to do some things about science policy and communication because I felt like teaching and talking about science was really cool. And I set some goals for myself in college. I wanted to learn what I like and don't like by trying new things or continue to do that. I want to learn more about myself and where I wanted to go. The next one, which was really big for me, was learning how to learn effectively and how to think about my own thinking. Because one thing that I noticed was that a lot of scientists who are really good at what they do are really skilled at these two things. It's not about the fact that they have, like they might have a ton of experience, but when a new problem is put in front of them, they're able to kind of adapt to the situation. And it is the ability to learn and the ability to keep an eye on how they're thinking, which really helped them out. I wanted to stay engaged in science and somehow contribute, make friends, have a life, and of course, get a degree. And so I became a biochemistry major, to test whether I was interested in the life sciences. And I also decided to major in neuroscience through psychology and brain sciences. The other thing I did, which you guys might want to think about if you're interested. Oh, we have a question. Give me a second. Did you have to make a hard choice about where you were going in college? Do people try to steer you away from UMass? Yes. There were two camps. First, there were people who felt that UMass, at least the way they said it to me, wasn't really, I wasn't going to have a lot of opportunities after that because of really the level of prestige versus other schools. That was what they said to me, and I completely disagreed with that. The reason being that University of Massachusetts is the biggest supplier of jobs in Massachusetts, or of people coming into their first job out of college in Massachusetts. And there was another field that really said, oh, you're going to save a lot of money. You're going to learn a lot. It's a great university. And you will have the chance to go elsewhere and test other things later on. So those were the two camps that really I encountered in my discussion about whether to go to UMass or not. But after I ran the numbers about what I could afford and where I wanted to go, financially, this was the only choice I could make. And it turned out to be a great one. So yeah. The other thing I did, I joined a special group called Icons, which was all about science and society and integrating that and helping undergraduates learn how to communicate their science and also like how to work with people who are outside of their field. So if you have a chance to think about those sorts of things in college, I would definitely take that opportunity. Next up, I went to New England Biolabs, which was a place that I'd heard about right near Masco in freshman year of college. Someone had mentioned it in my biology class. I thought it was super cool. I told Alia, my mentor at Harvard, about it, and she offered to recommend me because it turned out she had connections there. And so I sent in a cover letter and resume, which I, of course, asked Alia to review and take a look at. In my freshman year of college, I had a phone interview, and I ended up getting an offer to work there for the summer. And I actually spent 2 summers there developing reagents for polymerase chain reaction experiments. And I had some really good mentors there. In particular, someone named Janine, someone named Andrew. They really gave me the chance to start to design my own experiments, let me learn about how to solve problems on my own, that sort of thing. And they were really helpful for giving me career advice. I would go to them, I would ask all these different things that I wanted to know, like, what are your thoughts about like graduate school? And they'd let me know. I went to my first scientific conference. I did some scientific writing. And I felt that this biotech company was very laid back and there were a lot of resources. But one thing that I felt was lacking for me was that I wanted to be doing more work with disease. I felt like I wasn't close enough to helping patients directly. Sophomore year, I wanted to work in a lab at UMass, something a little more closely associated with disease. But adjusting to college was a bit hard for me as a freshman. There were some things going on outside of school that were a bit out of my control that left me distracted. And so I didn't really take the time to go and look for labs. But one thing that I really started thinking about was how one's environment can influence their biology. And because of a lot of these experiences, because of a lot of things that I'd learned about environment, like, so for example, my dad was at 9/11 and he was helping there. And a lot of people were exposed to all these different chemicals that gave them cancer. And so I was wondering, oh, this is important. This is something to consider. And I felt like this wasn't talked about. We talked a lot about genes, but not about the environment a lot. And so I want to learn about that. So I went to the on-campus Office of Undergraduate Research to learn about labs. And someone there, once I told them what I was interested in, helped me find different labs that I might be interested in and talk about how to reach out to them. And so I sent some emails saying to different labs, hey, I'm interested in learning about your research and I'd love to schedule a meeting to talk about it. And if you're interested in having me, I would love to work in your lab and learn from you. These were labs that I had looked at, I'd researched, I'd read their papers, and all of that beforehand. And one person reached out to me out of the multiple ones that I sent. His name was Dr. Suvorov. And I scheduled a meeting to talk with him about research. It wasn't the lab that I really wanted to go to. It wasn't the one that was explicitly focused on environment and biology, but they had some stuff in there. And I took the offer that he gave me because I wanted to do science. He initially wasn't really interested in giving me an offer, but after I told him how interested I was, how much I want to do this kind of biology that he shared that he was doing during the meeting, he decided to give me a chance. And it was a really big break for me. I also felt like Dr. Suvorov was really interested in teaching people science and helping me learn about how to do good science. And I could tell that based on how he told me about the work that he was doing. It wasn't about him at all. It was about solving the problem. It was about learning something new. And that resonated with me. The lab was very small. There were no graduate students at the time. It was me and him, really. And the lab grew. But at the start, it was really just me. And I felt that would be cool because I'd have a chance to do a lot more work. He'd be able to teach me more directly, that sort of thing. And it turned out my top choice lab ended up not being able to take me on. But later on, I would learn that I'd have a chance to collaborate with them anyway. And by the end, I felt that Sasha or Dr. Suvorov was a fantastic mentor. So I would not change things for the world. I learned about how different chemicals may influence disease risk. I went to conferences and talked with many different people. You can see here. I did a thesis research project presentation on how early life exposure to different kinds of flame retardants might lead to different kinds of diseases. It was the first project that I really took charge of and led myself. I wrote a paper on it. I'm writing a paper that hopefully will be published on it soon. And you can see me presenting here, as Ms. Fay mentioned. And I also published another paper with the lab, which was very exciting. Sasha or Dr. Suvorov explicitly said that he really wanted to help us get a chance to publish an undergraduate, which is very rare. It's hard to publish research as an undergraduate. And one thing that stuck out to me in my initial meeting with him was that he explicitly said, I want you to have a paper before you graduate. And that was really important. That was a sign that he was really there for me and he wanted to be in my corner. And so, yeah, that was a time that I enjoyed and I missed it. I miss it a lot. Some other things I did to test out whether I was interested in science and medicine was I worked as an emergency medical technician. I took what I got from Masco, what I learned there, and applied it. You can see us working a shift here at a football field. I helped just build a science communication podcast called A Little About a Lot, where people could learn how to communicate science, how to talk about it, not just like learn book knowledge, that sort of thing. In senior year, I started a club about science policy to help myself and a lot of other people get a chance to learn about how science and policy interact, which I've been learning was really cool. And I think we've seen that recently, that sort of thing is important. I also volunteered in hospice care, where I had the chance to learn whether I really felt like I could work with patients. And also personally, I wanted to contribute to people who are passing away and make their life better at the end because of I'd seen some people in my family pass away in ways that I wish were better. And so this is why I want to do that. And I really learned a lot there. And one of the things that I felt I needed to know, like I learned about how to talk with people, how to talk with patients, but what is the actual application of medicine like? What is the science behind clinical research like? And that was one thing that really I hadn't had the chance to do yet. And I'd spent freshman and sophomore year of college trying to find someone to shadow. Finding a doctor to shadow is really, really, really hard. I was desperate. I even went to an insurance company in Topsfield, who someone had told me like work with a lot of doctors, and try and schedule a meeting and asked if they could introduce me to anyone that I thought was qualified. I was absolutely desperate, and it didn't work out. But I had heard there was someone who worked at Dana-Farber Cancer Institute in town. I was going to literally just email him or mail him my resume, but I learned that we had a connection through my old Boy Scout troop. And so I went back and I connected with him through that. And when I talked to him about what I was interested in, how interested I was in it, my previous experience in the Suvorov Lab at New England Biolabs, all these other things, he said, oh, okay. I think it's appropriate for me to connect you with someone. And so it was really important that I demonstrated experience, that I had good academics, a strong interest in learning, and a willingness to take initiative and try and find opportunities. And so he connected me with this woman here, Dr. Lakshmi Nayak, at Dana-Farber. She's a neuro-oncologist. And so when I was there, Dr. Nayak and other doctors gave me an opportunity to follow them into the clinic and learn about all the clinical research they were doing. This was a pretty clinical research heavy office in summer of 2018. I got to see what it was like to treat patients and actually do clinical research. How do you talk to people and get their consent to be part of a study? How do you really design a good clinical trial so that you can answer the questions that you want to solve? I had the chance to learn that, and I loved it. And they also love to teach me what they knew. You'll find that a lot of people, if you ask them to learn, they will love to share what they know. I mean, like, look at me. I love talking about my own experience. And I'm sure most people do. So use that to your advantage. Keep that in mind. Let people tell you what they know. But asking questions to get them to share that sort of thing with you is important. And so that was one thing that I asked of these doctors here in the office. This is a picture of what the office actually looks like. I asked them these sorts of questions to learn whether this kind of career would be right for me. And it really reinforced my interests. And one thing I made sure to do was write down all the things that I learned, write down the contact information of different people that really I had learned a lot from. That's one thing I would strongly suggest. Stay in contact with people, learn from them, help build your network a bit. Because people are here. This is not a solo effort. Science and medicine is a team effort, and we're all here together. And so we got to help each other, and staying connected is all a part of that. One thing that really struck me was that Dr. Nayak said, research drives medicine forward. And that's why she always liked to stay involved in research. And that was really resonated with me. That was a way that I felt conceptually I could blend my interests in research and medicine. And so I really want to learn more about that. I hadn't had the chance to really be in a biomedical research lab, developing therapies and that sort of thing. So I went to try and look for it. I want to learn more about disease biology. And the person who helped offer me the shadowing opportunity, because I had learned a lot, because it seemed that it seemed like I was really gaining a lot. He offered to connect me with a lab that he was familiar with, the Meyerson lab. And so I sent in a cover letter and a resume, and I was invited in for an interview. I discussed my previous science. I learned a bit about what I would do. They couldn't tell me too much because what they were doing was proprietary. And I explicitly stated that I would not be able to work without an income. That was really one thing that was important for me. At this point, one reason I couldn't work at UMass in the summer was because I needed money. And so I made it very, very clear. I thought that the interview went badly. I thought that it wasn't going to work out based on the conversation. And there were no other opportunities that have been working out so far. So I had to meet up with a friend to calm down after, to debrief. Um, and, but they ended up giving me an offer, and they ended up being able to pay me as well. But it probably wouldn't have happened if I hadn't asked. And so I got the chance to learn a lot about basic cell culture, cancer biology, how cancer drugs are developed, and how to actually like bring a treatment from like just a drug to understand the mechanism and eventually bringing it to clinical trials. And I had a chance here. There were so many MDs and PhDs and MD PhDs that I had a chance to learn much more about like where I was interested in going than anywhere previously. But one thing I learned was that I miss working with patients because I was primarily doing research here. And one thing was that I ended up getting an offer to come back full time after graduating college because I had worked really hard while I was there, and I had a lot of training. They wouldn't have to train me again. They knew who I was, all that sort of thing. And so after reapplying again, I took it. I had to reapply for the job, but then I took the offer that they gave me. I had to come in, re-interview, all of that stuff. And so that's how I got to where I am. But what's next? My goal is to, based on what I've learned, really be a physician scientist. I do want to do an MD PhD program, as Dr. Stavas had mentioned to me at that running camp. I've rigorously tested it. I've gotten a chance to learn all the different parts of it, or at least have a little taste. And I know that I want to uncover disease biology. I want to develop new tools to understand and treat disease and apply the knowledge that I gain and the tools I develop in the clinic to help expand treatment options for patients who really don't have a lot of help right now. And I want the research that I do and my time in the clinic to really inform each other. That was one thing that really stuck out to me when shadowing. Like a lot of the research that they did was really strongly connected with a lot of what they were doing and the patients they were treating. But one thing I felt was that I needed 2 gap years, which I'm taking right now, to just confirm that a little more. Because an MD PhD program is 8 years plus a fellowship and residency or a postdoc. So really it's 15. So I'm dedicating myself for a long time to science. I want to make sure that that's what I want to do. My goals overall, as of now, are really just to be a PI, running a lab and visiting patients in the clinic a little bit. Also making science and medicine accessible to the public. That's one thing that's really stuck out with me since Harvard Life Sciences Outreach. That's one thing that's really stuck out with me since the start of the coronavirus pandemic. Also helping in a similar manner, helping to maybe when I'm an expert, translate between scientists and policymakers for specific issues. In my eyes, we've seen a lot of decisions being made, and it's really important that the people making the decisions at least have someone there who can help articulate the science to them in a way that they can understand. Not dumb it down, but explain it in plain, normal person terms. We have a chat. Yeah. Oh, yeah. PI means principal investigator. They're the head of the lab. Usually under them are graduate students. And then oftentimes when you're an undergraduate or you're working as a high school student, you might be working under a graduate student who's trying to get their PhD. So that's one thing to think about in terms of structure going forward. Also, one thing that I learned is just having a life is really important. I'm sure a lot of you are aware of that, but that I was not initially. And I really just want to help other people do what they want to do. That's why I'm here right now, because I want to help other people who are in the same kind of situation that I was in. So please reach out to me. I am a resource for you. Some things that I've learned so far, the best way to learn is really by asking questions. Passion is important. If I didn't come to Miss Faye and say, I want to do this, I will do what it takes. I don't know if she would have really been willing to offer this opportunity to me. Same with the person who offered to let me shadow, or or Dr. Suvorov who took me on. Passion is important, and don't let anyone tell you otherwise. It's not everything, but it's important. Persistence is also important too, because if you persist, you can make your own luck. If you try 100 different things, there's a good chance that one of them will work. So sometimes like when I was trying to find shadowing opportunities or when I was trying to find my first internship opportunity, powering through, you'll make your own luck. Thinking about how you're thinking so you can reevaluate yourself, reevaluate how you're learning and how you're perceiving as a scientist is going to help you in addition to what you might learn by just doing science over and over again. It will help speed your learning up exponentially. It will help you speed your ability to work as a scientist exponentially because you'll constantly be evaluating who you are, how you're thinking about all the problems you're trying to solve, and what specifically you're doing. The fancy word for that is metacognition. And I think in my eyes, all the good scientists are doing it. It is what we need to do. We need to make sure that we check ourselves and our own biases in a way. Another thing is, do you want to be right or do you want to actually solve the problem in the long term? You have to acknowledge when you needed to learn. And sometimes, especially in the beginning, this was hard for me. I had a little bit of an ego. And so learning that sometimes I'm not right and just acknowledging that I can learn something new really helps actually speed up the ability to solve problems. And yes, in the same lieu of that, saying what you don't know leads to better science. Ask for help when you need it because science is a team effort. Because if you don't know and you make something up, someone's going to prove it wrong. So keep that in mind. More lessons learned. It's okay to not know exactly what you want to do. Taking time to learn and test is helpful. But at this stage in the game, it's not about like the rest of your life. It's about getting a taste of what you might be interested in long term. I believe, I forget the exact statistic, but the vast majority of people don't stick with what they actually graduated with in college. So I would keep that in mind. Get a general understanding of the concepts and overall like problems you're interested in tackling, the overall ideas. Like, for example, I'm interested in disease. I'm interested in integrating science and medicine and policy and all these sorts of things. But I'm not necessarily tied to a specific pathway to do that. And for me, that mindset has really helped me not stress as much as I would have otherwise. So of course I'm stressing a bit. But yeah, knowing what you don't like is just as important as knowing what you do like. I've got the sense through working as an EMT that emergency medicine is not what I want to do long term. I want the chance to know patients a little more. I don't want to kind of get in there, give them a treatment, which may really save their life and it was really valuable. But I don't have the chance to connect with them and treat them in a holistic manner, which to me is really important. The other thing, take the initiative, ask questions, go seek out the advice, ask for the job or the internship. All the things that I did in this sense really snowballed. So I'd keep that in mind as well. But this is really all about how you will get there, not really about how I will get there. And I want to share my story a bit because it's an example. It's not the only example. I would talk to as many people as you can to get their stories. The way I did things is not the only way to do it. There might be a way that works much better for you. It is all about you. And I think the one thing to start off in thinking about that is really who can do science? And the answer is everyone. The reason being, we use scientific thinking every day. You, like maybe when you're cooking, you might test whether adding like a certain amount of flour to thicken your stew or maybe a smaller amount of flour is a good idea or not. And you actually make an experiment through your cooking. That's one way, like that scientific thinking where you have a control and a experimental treatment, or you test multiple different conditions, is really in use every day. We use it all the time and we might not think about it, but we do. An important question to ask yourself at this stage is, do you like the type of work that scientists do? And it may take a while to learn that. And it also might take a while to prove to yourself that you actually are capable of doing science, which can be done through testing and learning and actually doing hands-on experience. And it took a while for me. Other things, what can you actually do with science overall? You can take on some of the world's most challenging problems. You can help cure coronavirus or protect us against it. as we've seen with the COVID vaccines. You can send someone to space. You can help design new green energy and help save the planet. You can learn about human behavior, psychology, like how we think in a systematic, applied manner. You can analyze data and predict trends. And most importantly, you can help us prepare for the future and build upon what generations and generations of people have already helped us learn, which really the results of are around every day. Like we wouldn't know that germs cause disease unless people tested that. We wouldn't know that we can actually survive diabetes unless we tested that. We wouldn't know if we could cure cancer, if we could go to space, if we could cure COVID, all those sorts of things. So I would definitely keep that in mind. There are a lot of big problems that you can solve. You can help us grow as a society, but it's also a responsibility because your science, and depending on how you share it, can help lead society in the right or wrong direction. It's important to keep that in mind. And that's why I think science policy is key as well. So yeah, I definitely think about that. There are some specific career paths that involve science as well. Also, what time are we at? Because I can't see the time right now.
4:49.
Oh, okay. I got to speed it up. My apologies. Working as an academic in research, working in industry, in medicine, or in industry meaning like a biotech or developing like different reagents for use in a lot of different fields. Public health, science communication and journalism, law. Really, there are a lot of different places. And I'm going to skip this. But as I've said before, knowing whether a scientific career is right for you really starts by experimenting. Take some classes, do internships and hands-on experience, talk to people who are in places where you're interested in going, and start to think a bit about what you might want to do next after high school. I chose college. There are a lot of different options. The other thing is there's nothing wrong with not doing science. We need a lot of people in a lot of different fields, but understanding scientific thinking is really important everywhere. Just know that what you might want to do now may change completely. The most important thing is to get started. For those of you who are thinking about going to college, some questions I might keep in mind. I apologize that I'm breezing through this, but I want to keep this a little more concise. Is really what at each college can you learn what you want to there? One reason I chose UMass was because I really saw that there were a lot of research opportunities for undergraduates. How easy is it for you to access those kinds of opportunities? How is it easy for you to get a job there, to get scholarships, that sort of thing? The secret goal of college as well is learning how to learn, because after college, you might be doing something completely different, but the most important thing is being adaptable and learning new things. So I would definitely keep that in mind as well. Ask yourself what you want to get out most of this, or what you want to get out of those 4 years, and definitely start thinking about and evaluating how you think. For now, if you're interested in an internship, which I would imagine that some people at Masco may be, if like just starting out in high school, talk to people you know. It's often the most effective way to find opportunities that you don't know about. So for example, teachers like Miss Faye, or family, friends of parents. Maybe you have specific school programs that can help you out. And also the internet is your friend. There are a lot of different opportunities out there for you. Just look up Massachusetts high school research opportunity, and you'll have a lot of different ones pop up. There are a lot of research opportunities for high school students out there, and it's just the important thing is figure out how to find them, which my goal is to, if you want to connect with me later on, help you do. One thing to note is that most students who do research start in college. So if you get a chance to start in high school, that may give you almost a bit of a taste earlier on. You might know more going forward. More on starting in science, just take the little steps. Take your classes, do some research projects, read some papers. All of these are really important. Don't discount them. Make good use of your time when you're in college, maybe during the summers in high school too. Try and get some experiences if you can. That was really where I learned the most about whether I like science or not. And another thing that I don't think anyone has told me before is to create your environment. Find places, put yourself in a place where opportunities are more likely to come up. Put yourself where people are more likely to want to help you physically. Yeah, so another thing, this is a cool app that I want to share. It's called My STEAM ID. It was recently made by a Harvard graduate student, and it's all about helping simplify the way to find internships for high school, undergraduate students, postgraduate students, really everything. So maybe I can send a link to this later, or you can see it in the video afterwards. But this might be a useful tool for you. I went through and I looked to see if there are any high school internships, and there definitely are. A lot of them are virtual. So that might be important. Another thing I'm gonna just plug is that the Broad Summer Scholars Program is taking on applicants, or they will be soon, for this upcoming year. Let's see, we have another question. Oh, perfect. Thanks for the link, Mr. Bigler. And I would definitely take a look at that if you want to learn about research here at the Broad. Another thing is talk to your network. Use the connections that you have from the people that you know. And also, you have a new connection, me. If you haven't really done a lot of networking, if you don't really know much about it, you're kind of nervous to do it, I am your first connection. And so feel free to reach out to me whenever you want, whenever you have a question about science that you think I might be able to help with. I'm here for you. And we have another question. Yes, Kevin, I'm going to share my email with you, and I'll make sure that you get that. And so Miss Fay will also have it, but I'm gonna share it on the slide here as well. Some final bits of advice before I wrap up. I apologize if this was a bit more lengthy than I anticipated. I got pretty into it. And I hope you enjoyed this as well, I hope you find it useful. Oh, give me a sec. If you don't see an example of what you want to do, be the example, make your own path. Say, screw it, I'm gonna do this first. I'm gonna help make the road for everyone else. And so that's the thing, for me, the lack of examples that I felt was at UMass was in science policy. So that's why I made that club. Oh, another question. Yeah, go right ahead. Feel free to use the email and the PowerPoint. I'll share that with you. I feel comfortable sharing that. There's nothing that's confidential or anything like that on here. The other thing is that, and I learned this the hard way through college, that I went through some hard times where all I was doing was working. Like literally all I was doing. Friendships, fun, healthy relationships, all of those are absolutely critical to quality of life. In my eyes, a career is not your life, nor should it be. If you want to, that's fine. But come the end of the day when, for example, like I saw a lot of these older people in hospice, at the end of their lives, the only thing they want to talk about is their family and their friends and their memories with people. So I would definitely keep that in mind. Contributing to science, contributing to a scientific career is important, and it can save a lot of lives. It can change history. But at the end of the day, when you're near the end of your life, what do you think you'll value? And for a lot of people, it's their time that they spent with others. Focusing on a specific career can also be helpful. Oh, got another question. Give me a second. You're applying as a biochem major, but don't know what career path I want and don't know what questions to start asking people in these fields to figure it out. Do you have any suggestions? I think the most important thing, if you're applying as a biochem major like I did, is really to just, like when you get to college, start asking some of your professors like what their story was. I think learning more about people's stories, if you don't have a specific question, is a good way to find things that you're interested in. Ask like, how did you get into science? Where did you come through? Then, yeah, I'm trying to think of some other things. Talk to your teachers. Talk to your teachers at your high school. Even honestly, I would suggest just cold emailing some scientists that you think are really cool. Tell them, hey, I'm a high school student who's really interested in your research. I want to learn more about how you got there. Is there any chance you could tell me a bit more about your story? Like, could we have a meeting? That sort of thing. Like, could you spare like half an hour of your time? That sort of thing. And a lot of scientists, I've learned, really value taking the chance to help people who are just starting out. It gets a little harder as you are like once you graduate college and that sort of thing. But I use the fact that you are not even an undergraduate and you're just starting out to your advantage to connect with people to share information with you. Specific questions, I think a lot of that for me was I learned the answers to those by asking people stories and just testing those experiences myself. I didn't know what questions to ask, and honestly, starting out, it's hard. I apologize. I don't necessarily have any specific questions beyond that. Aiden Venkas asks if there are a lot of internships for freshmen or just seniors. And it really depends on which internship you're talking about. If you get a chance to work at a lab through someone you know, oftentimes it's easier if you're younger, if the mentors are willing to take you on that young. But a lot of times, usually high school internships are for seniors. Yeah, I keep that in mind, especially starting earlier on in high school, maybe get a taste of like the different kinds of science that you like. For me, the one that stuck out was like the life sciences. Yeah, and then I would start looking for internships for your senior year, maybe your junior year, because also taking some of these classes so you have a little content is important too. Starting as a freshman might be hard. Let's see. One of the common threads in your talk is about advocating for yourself and being willing to step out of your comfort zone. Do you have any thoughts, advice for students who have a hard time doing that? Yeah, I had a hard time doing this too. I think take little steps. It's really hard, and often you don't know how to jump really far out of your comfort zone immediately. I might start by asking like someone in your family who knows about science. Hey, like, what was getting a PhD like? How did you learn that you were interested in science? Like someone that you're already close to. And as you start to practice asking these questions more and more, you might feel more comfortable reaching out to like teachers or to people you know or you somewhat know who work at a biotech company, or even people you don't know at all. But I take little steps. I think it's practice and it's demonstrating to yourself emotionally that you can actually jump out of your comfort zone, and it's okay to take the risk. And the worst thing that can happen is someone says no to you, just straight up, and tells you no. And then all that happens is that you're back to square one. It won't push you back any farther than you were initially. That's the advice that I'd have based on what I know so far. Little steps are important. Do you have to excel in advanced bio and chem classes in high school to succeed or work in the field? No, not at all. I think there's a very big difference between doing well in a class where there are specific benchmarks and like specific answers on tests, and working in science where you don't know what the answers are. What's more important is knowing how to figure out the answers yourself. I'd say resourcefulness and the ability to learn how to learn are more important than getting good grades. And I think, like, for example, when I started out doing chemistry in Miss Lund's AP chemistry class, on my first test, I got a 63. I almost failed. But keeping some of these things in mind, like thinking about my thinking, asking questions, trying to step out of my comfort zone a little bit in class was really what helped me start to do better by the end of the year. And also that kind of theme was really important for me going to college. I wasn't really, starting out, I wasn't necessarily the most apt, but at the end, I was rocking. I was doing well. And that was because I wasn't doing it alone. I had a lot of people who were there to help me. And so I'd keep that in mind too. But the short answer is you don't have to excel. You have to be able to like pick up a pipette, know how to design and experiment, maybe have some of your questions. I think asking questions is more important than knowing the answer. So yeah, soft skills, the ability to communicate your science and ask questions are very important. And lastly, I'm going to say it again, remember to think about how you think. And yeah, that's all I have. This is my contact info. I have an email, a Twitter, and a LinkedIn that I like to share with people. I think the email is most important.
We're
If you have any
getting
more
some-
questions, feel free to type them in the chat or ask them. And I would love to help you however I can. So feel free to reach out after. I am here for you. I'm on your side. I am part of your team. And I am a part of your network too. So yeah, thank you for having me. And I'm happy to take any more questions. Oh boy, we have some messages. Give me a second. Oh, thank you. Thank you. Yeah, this means a lot to me that you guys valued this. I think all I want to know is that like I'm helping people in the way that other people help me. And I'm giving a chance to share info that I wish I would have had earlier on. Yeah, I can definitely put my email in the chat. Give me a second. I need to switch this to everyone. It's jmcgunn14@gmail.com. And my name is Joseph McGaunn. If you email me or search me, you'll be able to find me. I'm the only Joseph McGaunn in the country, which is very weird, but it's cool. What was the app called? It's called My STEAM ID. And higher up in the chat, a link to it is there. It's mysteamid.org, not mysteamid.com. So yeah, let's see. Okay, one second. I got a private message here. Many places. I just have to know how to find it. Yeah. Often I would suggest talking to teachers who might have a specialty that you're interested in. So for example, with Miss Faye, she's a specialist in the life sciences, and that's how she gave me some guidance as to where to go. Yeah, let's see. Any other questions? Cool. I think that's all. If anyone else would like to jump in, anything that I missed that some of the coaches might not have thought about, go right ahead. This is, I think, this should be more of a discussion. I know I've ranted on long enough, but I'm happy to have shared my story and given a little advice that might be helpful. And thank you for listening. And if anyone else has any other questions, yeah, feel free to email me right now. I just got to review the PowerPoint one more time and I'll shoot it to you. But I'll also share it with Miss Faye as well. So yeah.
Perfect.
Cool.
So Joe, thank you. There was so much information in there, and I had some notes to myself. And one of the things I would put out there in front of everybody, including my students, is that I consider myself to be motivated, and I had some similar motivations as you. I didn't do what you did. I wish I had more. It might have been more confidence and more ability to work through some of those things to find some of the things that you're talking about. I think you gave examples for students on so many different aspects about how you got there, and you really exemplify that you think about how you think, and you're thinking about how to get there. And your energy and passion. I would put out there, one of the things I asked the question about the UMass because I think there's so much pressure for students to go to particular schools, that there's reputations associated with them. I appreciated your honesty around the monetary aspects related to trying to attend school and afford school. And I know for a fact that you were accepted at prestigious schools, and that you could have gone to other places. And I think you've shown that you can make things happen. And you found ways at UMass to really highlight and pursue the things that you're interested in. I find that you are inspirational for young people, and I thank you for taking the time. And those of you, he mentioned earlier, I wasn't sure whether to give Joe an internship. I flat out honest, I didn't know Joe. I knew that he was persistent. He was persistent when he spoke to me. I did go to Miss Lund, the woman that he mentioned, and I said, Miss Lund, what can you tell me? Should I give this kid an internship? I'm putting my name on the line. I don't know him. I don't know if he's a good student. And sometimes that lesson for me is also about networking and taking risks on things that you may not be comfortable with, but finding out and then going, you know what, I'm going to do this. And it's clear that from my perspective and your perspective, that was an important pivotal moment early on and getting you some experience to practice something. So thank you for sharing all of that. Anybody else, anything that you would want to say to Joe?
I have one last thing to add, and actually, I've just been starting to think about this recently. One mindset change that has been really helpful for me in terms of being able to be motivated is really, how should I put it? I think initially I was afraid to talk to people because I was thinking things like, will they be upset at me if I ask? Like, would they yell at me? Like that sort of thing. Like, what are the negative consequences? What could happen to me if I ask these questions? But if you frame it in a way that it's not about you, it's about solving the problem. It's about growing so that you're capable of contributing. And the end goal is not to help you, it is to help other people. At least for me, I felt like that was recently, that's one thing that's been sticking out to me in a way as something that has helped me feel more comfortable asking questions of other people and kind of networking and getting out of my comfort zone, kind of forgetting about myself and thinking about others. Not that you should do that all the time. But yeah. That's all I got.